Yesterday we talked about the Pythagorean theorem. The Pythagorean theorem can be used when you have a right triangle. And Pythagoras, a mathematician, found that when you take the measures of the squares, so let's say it's 3 and 4, when you square them, it equals the square of your hypotenuse. A squared plus B squared equals C squared, and C is your hypotenuse. And it was kind of a new thing to talk about taking the square root. So the inverse operation to squaring, so to get rid of that value there, we take the square root. They are opposites, so now we just have the x alone on that side, and we found that the hypotenuse for this triangle is 5. Now, the distance formula is derived from the Pythagorean theorem, and it looks very confusing. So before I write it in that big box up there, let's come down to this picture. From A to this point is 1, 2, 3, and from this point up is 10. And then we've got this distance from A to C, and that's what it's asking us to find. Find the distance between the points A and C. Well, it's a diagonal. So unless I had a ruler that had these exact same measurements, even then it would be estimating because it's diagonal. It's not full units. It's partial units. So what could I do to find that distance? How about now? Well, I've created a right triangle. By the way that I've connected these 2 points at a right angle, I've created a right triangle. So I can use the Pythagorean theorem, where I've got 10 squared and 3 squared So now it should look kind of like yesterday on the Pythagorean theorem. If I know c squared, how do I get it back to just the c? Well, the inverse operation of squaring is square rooting. Oh, I'm going to need my notes for this. I do not know in my head the square root of 109. And it looks like it's 10.4. It didn't say to round to any specific, but in general, we've been rounding to the nearest tenth. All right, so sometimes as you look at example 2, do you see how there's not a graph? They're just giving you 2 ordered pairs. So what I'm going to show you is how you would find the distance between those points when all you're given is ordered pairs. If I take the 2 values that they give me that are x values and I subtract them from one another, I'm finding the horizontal distance. And I do that by taking x2 minus x1 and squaring it, just like on the Pythagorean theorem. That would be our A. Also, like the Pythagorean theorem, I would need to add that. Let me add squared there, sorry. To find b squared, that's the vertical difference. So this one here is x2 minus, oops, I wrote that funny, x2 minus x1 will find you this distance. y2 minus y1 will find you this distance. So that's the next thing we'll do. By finding those values and squaring them, it's helping me find the distance or the hypotenuse. And then what did we do the very last step yesterday to find that hypotenuse? Well, we took the square root of that value. So please draw that square root symbol over your entire equation. Okay, make sure you've got that written down. I'm going to finish that up there. Okay, let's go down and look at an example with ordered pairs. The first thing that you should do is label your x's and your y's. So this is my first ordered pair, so I'm going to label it x sub 1, y sub 1. And this one here is my second ordered pair, so I'm going to label it x sub 2, y sub 2. This is your first one, it should be the 1's. This is your second one, it should be the 2's. Step number 2, plug your numbers, -1, 4. negative 3, negative 4 into the formula. Okay, so what do I do first? I do a set of parentheses, and then x2, which is negative 3, and then a minus sign, and then x1, which is negative 1. Now, a lot of kids don't like to write minus negative 1, although that's correct. Most kids will change that to a plus sign. That looks really ugly. Let me fix it. Okay, moving on. I'm looking back here, plus. And then a parenthesis. And then I put in my number that's for y2 in this equation, or in this problem, it's a negative 4. Then the minus. And then I look here at y1. y1 is a 4, and square to the power of 2. All right, I like to do a lot of this by hand. You're welcome to punch this into your calculator and see what you get. But I'm going to do negative 3 plus 1 is negative 2, and negative 2 squared is 4. Negative 4 minus 4 is negative 8. Negative 8 squared is 64. Maybe it's because I'm a teacher, but I like doing some of that in my head. So most students are going to punch this in their calculator and kind of skip that middle step. They'll go straight from the big formula to the square root of 68. So put that in your calculator, and I'm going to round to the nearest tenth again. Can you see why even if you had a ruler, 8.2, it would be very difficult to be accurate, I think. Okay, so perform the order of operations under the radical. That means adding, like parentheses, exponents, multiplication, division. So you saw me over here, I did adding, exponents, that's where the 4 came from, adding, exponents, that's where the 64 came from. So parentheses, exponents, there's no multiplication, division, but I did add those together, and then finally the square root. Take the square root, it says leave it as a radical, we're not doing that. Okay, if you go look at number 1 on your homework, oh, that's not what I meant to do. If you go look at number 1 on your homework, it's going to look like this, except not with that circled. Please don't go too fast on these first ones. Be careful. Step number 1, label. This is my first ordered pair. This is my second ordered pair. So these are x, y with the ones, and x, y, like x, y, z. It's like alphabetical order. Some people are like, which one goes first? Well, think about the alphabet. Q, R, S, T, U, V, W, X, Y, and Z. That's how you know the order it goes in. Step number 2, plug these into your formula. So open parentheses. Let's plug in the number that we've got for x2, which is a 7. And then I do the minus sign. And then I come and look what I have for x1. It's a negative 4. So minus negative 4 is going to become a plus. Bring down the squared, bring down the plus, open parentheses. What do we have for y2? Negative 2. Bring down the minus from the equation. Come and look at y1. Negative 5. Negative 2 minus negative 5. You're welcome to write negative 2 minus negative 5. Your calculator won't care if you have it like that. Your calculator won't care if you have 7 minus negative 4. Your calculator doesn't mind that at all. These are both perfect. In fact, this might be easier for some of you to keep track of. So punch that into your calculator. Again, I like to do a lot of it by hand. I'm not sure why. Oh, why did we do that? There we go. I think my sleeve keeps touching the screen. So I know this is 11. I'm doing the parentheses. I know that 11 squared is 121. And here, negative 2 plus 5 is 3. 3 squared is 9. So my distance now is the square root of 130. Put that in your calculator. Sorry, I'm going to get my answer key. And I got 11.4. So my biggest thing on your homework at the beginning, don't go too fast. Some kids started doing x1 minus y1 squared. That's going to give you the wrong answer. Remember, when we subtract these x values, we are creating sides of a right triangle. So on this one, we found that this side, well, I didn't do it long enough. We found this is an 11 unit side. And when I subtracted the y's, I found that they were 3 units apart. If you're subtracting x's and y's together, you are finding nothing useful for the hypotenuse or the distance. I wish that was straight. Oh, and then we do a squared plus b squared equals c squared. This is the Pythagorean theorem. We're just not drawing pictures every single time. So same idea on number 2. Let's label them. Okay, so the distance is big, huge square root. It's open parentheses, x2 minus x1, negative 6 minus 6. y2 minus y1. If that bugs you, change it to a plus. Your calculator does not care. All right, negative 6 minus 6 is negative 12. And negative 12 squared is 144. 7 minus negative 2 is 9. 9 squared is 81. If you punch that into your calculator, you'll go right to the square root of 225, which is a perfect one. So again, this one, when I subtract my x's, I'm finding that this is 12. When I'm subtracting my y's, I'm finding this is 9. And then when I calculated my hypotenuse, it's the longest of the sides. These are called Pythagorean triples. These ones that are all 3 whole numbers, 9, 12, 15, a Pythagorean triple, which is kind of cool. Okay, the homework is the distance formula worksheet. On these ones at the bottom, oh, I don't even know if I can recreate it. So if you've got, I think it looks like this kind of, and I want you to find the distance. You count. You count. Use the Pythagorean theorem.